In cellular communication, inter-cell interference has always been a major concern. In second-generation communication, the operators divided the allocated bandwidth, and cells in the vicinity use different frequency to operate. The technique is popularly known as frequency reuse. But with the evolution of communication, the users became data hungry, and operators had to allocate more resources to the users, or provide them with more bandwidth. To overcome this, a frequency reuse factor of 1 is used in 4G. That is, all cells uses same frequency. As a result, at the cell edge, users may face inter-cell interference. So what did the operators came up with to mitigate this issue? Hello everyone, welcome back to the fundamentals of LTE. Today we will see how using multi-point coordination, the user experience at the cell edge is improved by exchanging cell information among different base stations. The prime motivation of coordinated multipoint, as described by 3GPP, are to improve the coverage, to improve the cell edge throughput, and to increase the overall system throughput. There are primarily two types of coordinated multipoint. Number 1, intra-site coordinated multipoint, where multiple sectors of one inode B cooperates. The advantage of intra-site coordinated multipoint is that significant amount of information can be exchanged, since the communication is within the cells of same inode B and doesn't involve the backhaul. Number 2, inter-site coordinated multipoint. This involves coordination of multiple inode Bs. It puts additional burden on the backhaul as lot of information is exchanged. Now, there are two ways by which coordinated multipoint operates. The first method is called joint processing. In this method, for downlink transmission, data is transmitted to the UE simultaneously from a number of different inode Bs. The aim is to improve the received signal quality and strength. In uplink, the PUSCH is received at multiple cells. The basic concept behind this format is to utilize antennas at different sites. By coordinating between the different inode Bs, a virtual antenna array is formed. The signals received by the inode Bs are then combined and processed to produce the final signal. This technique allows for signals that are very low in strength or masked by interference to be received with few errors. In both uplink and downlink, the joint processing method places a high demand onto the backhaul network. A lot of data needs to be exchanged between the coordinated inode Bs. Depending upon the number of inode Bs involved, this data may be double or triple. The second method is called coordinated scheduling or beamforming. In this case, data to a single UE is transmitted from one inode B. For downlink, transmit beamforming weights are generated. Based on it, the scheduling decisions as well as any beams are coordinated to reduce the unnecessary interference from other cells. As a result, the cell edge user throughput can be improved due to the increase in received SINR. In uplink, the UE transmits the physical uplink shared channel using a resource block to a single cell. The scheduling decision is based on the coordination among the cells. This format provides a much reduced load in the backhaul network because only the scheduling data needs to be transferred between the different inode Bs that are coordinating with each other. The major challenges faced in coordinated multipoint transmission reception are efficient feedback compression, reduced feedback delay, efficient channel prediction at the precoder, flexible formation of cooperation clusters, handling of outer interference within the cluster, efficient multi-user selection, flexible networking behind coordinated multipoint, integration of coordinated multipoint into higher layers, and reduced cost of base station synchronization and low phase noise transmitters. Now, one of the key requirements for LTE is that it should be able to provide a very low level of latency. The additional processing required for multiple site reception and transmission could add significantly to any delays. This could result from the need for the additional processing as well as the communication between the different sites. To overcome this, it is anticipated that the different sites may be connected together in a form of centralized RAN or CRAN. So friends, we have seen here that coordinated multipoint enhances the overall system performance through dynamic coordination among multiple geographically separated eNode Bs or cells from the same eNode B for transmission and reception. In our next video, we will see how throughput is calculated. You can post your doubts in the comment section. Happy learning!